Hello, welcome to the class of IPv6. So today we are going to discuss about the IP security. So in this class we will discuss about the what is IP security, and in that we will discuss about the security traits. Then non-reportization, IP security, security associations and the key management. So let's first start with what is security traits. So there are two type of traits that are defined by the security standards, that is CIA and triple E. So here the CIA stands for confidentiality, integrity and availability. So here the confidentiality is stored or transmit information cannot be read or altered by any unauthorized party. Whereas integrity it means any changes of transmitted or stored information can be detected. After that, the availability is the information in question is readily accessible to unauthorized user at all time. It means if it is accessible or not at all time. After that, the next part is the triple A, that is authentication, authorization and accounting. So authentications here stands at the act of clarifying a claimed identity. That means the person like adding a username password. So it is a way of authenticating a user like adding a ATM card pin. So these are the examples in the authentication process. After that, authorization ensures that the authenticated user or a group has the proper right to access the information they are attempting to access. So these include the access control list, and these access control lists contain the name of the authorized user. After that, accounting is the act of collecting information on resource usage, like the logs of HTTP server. So these are the two traits of security standard in IP security. And the next part is non-reportization is not included in CIA and in AAA trait. So here the non-reportization means at specified actions such as sending, receiving detail of information, and that cannot be detained by any of the parties involved. So this is mean non-reportization. It means we are sending and receiving information that cannot be denied by any of the parties involved. So there are two security elements in this: the encryption and the secure checksum and hash. So these two security elements provide the confidentiality and the integrity. So here the encryption as the combination of both result into a complex service such as authenticity and the non-reportization process. So encryption here provides the confidentiality, and it is further divided into two parts, that is secret key cryptography and the public key cryptography. So the secret key cryptography is the symmetric key encryption. Here, the sender and receivers agree on a shared secret keys that is used to encrypt and decrypt the information exchange. An example of secret key cryptography are like advanced encryption standard, the data encryption standard, the international data encryption standards, and the Ronald Rivest 4. So these are the various algorithms that we can use in a secret key cryptography. The next part is the public key cryptography. So here the two type of keys are used, the public key and the private key. The public keys are accessible to anyone whom we are not trusting or whom we are trusting, and private keys are only given to a trusted user. So here the asymmetric cryptography has two primary use cases like authentication and confidentiality. So using asymmetric cryptography, message can be signed with a private key, and then anyone with the public key is able to verify that the message was created by someone possessing the corresponding private key. So here the example of this like LGAML algorithm and the ECC, that is elliptic curve cryptography. So these are the example of public key cryptography. The next part is the secure checksum and hash. So it provides the integrity. So the combination of both will lead to the complex security system, and here the IP security standard use a combination of algorithm choices based upon the symmetric and asymmetric cryptography as well as on the one-way hash function. Next is IP security. So IP security is specified in RFC 4301 and it defines the security architecture for both IPv6 and IPv4 version. So it creates a boundary between the protected and unprotected area. And the security requirement in IP security is defined by a security policy database, that is SPD. So here the IP security defines like the description of security requirements and mechanisms at the network layer, and how to use cryptographic algorithm for encryption and authentication. Then the security policies and security associated with communication devices. Then protocol for encryption like encapsulating security payload, and protocol for authentication like the authentication header. Then the last part is the key management. So these are the part of IP security. So next we will discuss about the security association, that is SC. So SCs are the set of agreement between the communication devices. So there are three elements of agreement between the communication devices like the keys, inscription or authentication, and the additional parameter for algorithm. So here the SCs are unidirectional, that means each security service requires the separate SC. This means that two communication devices who want to encrypt and authenticate a two-way communication need four assays, one pair for encryption and the other two pair for the authentication. So then these assays have the two mode of transport. The first mode is transport mode. So assay is made between two communication devices, and encryption or authentication for payload of all IP packets is done in this transport mode, and the IP header is not encrypted in particular mode. After that, internal mode. This is a method that a SC mode between two security gateways are consistent, like the two security gateways are like a firewall. So here the whole packet includes the original IP address is encrypted or authenticated by encapsulating into a new header. This means this is a foundation of VPN, that is the virtual private network. So these are the two modes in between the assay, that is transport mode and the tunnel mode. The next part is the key management. So IP security use the cryptographic key, and these support the manual and automated distribution of the key. So IKE, that is Internet Key Exchange, specifies a protocol that allow for the exchange and negotiation of parameters for ASIC. So the first one is IKE version 1, that is Internet Key Exchange version 1, and Internet Key Exchange version 2. So as IKEV version 1 is not approved, also that why it replaced by the AKE version 2, but now it is widely used today. So the first one is IKE version 1, Internet Key Exchange version 1. It is specified in RFC 2401 and it is updated in RFC 4109. So this includes the three protocols like ISA-KMP, that is Internet Security Association and Key Management Protocol, which specify the framework for the management of SC and key exchange. So it doesn't specify process in detail, but it supports different key exchange mechanisms. After that, the Oakley key determination protocol, it is used in the exchange of keys and it is specified in RFC 2412. So here the extension of algorithm is defined by the Diffie-Hellman and it is only used the subset of the function of this protocol. After that, the next part is SKEME, that is the versatile secure key exchange mechanism for the internet. So here it is a fast key exchange technique. It defined in IEEE proceeding of 1996 synonyms on network and distributed system. So here it only use the subset of function of this protocol. So here IKE version 1 use the UDP on port 500 and 4500. This is about the Internet Key Exchange version 1. The next is version 2, Internet Key Exchange. It is specified in RFC 5996 and it brings the enhancement in the IP security while using with NAT for authentication and for remote address acquisition. So here it simplified the simplified use of IKE is by replacing 8 different initial exchange with single 4 message exchange. So it reduces error due to reliable protocol as all messages are sequenced and acknowledged. So this is the information about the Internet Key Exchange version 2. So this is all about the IP security in IPv6. Thank you.